Welcome to AlphaNumericTricks. In this video, we are going to see the short questions with answers using the properties of eigenvalues and eigenvectors. Under the topic eigenvalues and eigenvectors, we will see the short questions with answers. Under the topic matrices. Okay. Now we will see the first problem. Find the sum and product of eigenvalues of the matrix which is given as A is equal to minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Now we will find the solution for this using the property of eigenvalues and eigenvectors. The sum of the eigenvalues using the property of eigenvalues eigenvectors is equal to trace A or the sum of the principal diagonal elements. The sum of the principal diagonal elements are that here minus 1 and minus 1. Main diagonals is the sum of the principal diagonal elements. We had to add all the three numbers to get the trace A or sum of the eigenvalues of A, which is equal to minus 1, minus 1, minus 1. When you are adding that, you get minus 3, which is the sum of the eigenvalues of a given matrix. Next, we will see product of eigenvalues of a given matrix, which is equal to determinant A using the property, which is the determinant of a given matrix, which is equal to, we have to find out the determinant. First, you have to take that minus 1, first diagonal element, minus 1 into leaving corresponding rows and columns. Remaining numbers or elements you have to consider. Write it here, minus 1, 1, 1 and minus 1. Next you have minus, the formula you have minus. First you have a plus term and then the first element minus, after that minus the second term into corresponding leave the rows and columns, you have to leave it. Remaining numbers you have to write it 1, 1, 1 and minus 1. Write it here 1, 1, 1 and minus 1. Next in the formula you have a place. The last number you have is 1. So 1 into, okay, the minus corresponding rows and columns you have to leave it. The remaining numbers of that element you have to write it. That is leaving that corresponding rows and columns of 1. Remaining elements you have to consider 1 minus 1, 1 and 1. Write it here 1 minus 1, 1 and minus 1. Sorry, that is plus 1. Not a minus 1, it is plus 1. Okay. Now we have to multiply this. Always you start with here minus 1 into minus 1. Cross multiply that. Minus 1 into minus 1 is plus 1. In minus 1 into 1 is 1. So 1 minus 1 you have to write it here. Minus 1 into 1 minus 1. Next minus 1 into minus 1 minus 1. Okay, 1 into minus 1 is minus 1. Minus 1 into 1 is 1. So minus 1 minus 1. Plus that 1 into plus 1 is 1. 1 into 1 is 1. Minus of 1 into minus 1 is minus 1. So 1 minus of minus 1, it becomes plus 1. So write it here. That is 1 minus of minus 1, which is equal to minus minus, it becomes plus. So 1 plus 1 you have. Okay. So when 1 minus 1 get cancelled, that is 0. And minus 1 minus 1 you have minus 2 already, that is multiplied with minus 1, so you have a plus 2. Plus 1 plus 1 is 2, 2 into 1 is 2, which is equal to plus 2 is 4, which is the product of eigenvalues using the property of eigenvalues and eigenvectors. Now we will see the next problem. Two of the eigenvalues of a given matrix A 2, 2, 1, 1, 3, 1 and 1, 2, 2 are equal to 1 each other. Find the eigenvalue of the given matrix I inverse. That is, sorry, we have to find the eigenvalue of A inverse. You have to find it out. So using the properties, we have to find out the solution. Okay, so the problem, it is given that two of the eigenvalues of the matrix is equal to 1. That is, lambda 1 is 1 and lambda 2 is 1. We have two eigenvalues which is equal to 1. We have to find out the eigenvalue of A and then you go for eigenvalue of A inverse. Okay. So for that, again, we have lambda 1 is given, lambda 2 is equal to 1. Both are 1, it is given. Using the properties of eigenvalues and eigenvectors, we have to find out the solution. We take the third eigenvalue of the given matrix. The third eigenvalue of a given matrix be equal to lambda. The other two eigenvalues are 1 and 1 is given. And then sum of the eigenvalues is equal to trace A using the property because two eigenvalues are given. So this property is suitable for that. So sum of the eigenvalues is equal to trace A. So already two lambda values are given. Lambda 1 plus lambda 2 plus lambda 3 is equal to trace A. We have to write it. And lambda 1 is given, substitute as 1, and lambda 2 is equal to 1 plus lambda 3 we take it to be lambda, or you take it to lambda 3 itself. Nothing wrong in that. Anyway, you can take it. And which is equal to trace A is sum of the diagonal elements, that is 2, 3, 2. This is the, you have to add all the 3 diagonal elements, 2 plus 3 plus 2. So anyway, you can take it either lambda or lambda 3. Nothing wrong in that. 2 plus lambda 3 is equal to 7, or lambda 3 is equal to 7 minus 2. That plus 2 comes to other side. It becomes 7 minus 2, which is 5, which is the eigenvalue of A. Eigenvalue of A inverse, we have to find it out. So eigenvalue of A is 1, 1, 5. Okay, that is the eigenvalue of A. Eigenvalue of A inverse is, you have to take the inverse. 1 inverse, 1 inverse, 5 inverse, using the property of eigenvalues. That is 1 by 1, or 1 by 1 you take it as 1, and 1 by 5. 5 inverse can be written as 1 by 5. Okay, so this is the property of eigenvalue of A, or eigenvalue and eigenvector of the given matrix A. So eigenvalue of A inverse is 1, 1, 1 by 5. Next, we will see the third problem. The product of two eigenvalues of a given matrix is 16. Find the third eigenvalue. Okay, the product of two eigenvalues is given to be 16. We have to find out the third eigenvalue. In the previous problem, it is given that there is only difference between the previous problem and this problem is, the previous problem, two of the eigenvalues are given. And here we product of eigenvalue is given. Two eigenvalues is given. So the property will be, which property is suitable here? We have to use the product of eigenvalues is equal to determinant A. So in this problem, it is given to be lambda 1, lambda 2 is equal to 16. So this property is suitable for that. Okay, for this matrix, this property is suitable for this. So we take lambda 1, lambda 2, lambda 3 be 3 eigenvalues of a given matrix A, and we have to find out the product of eigenvalues using the property of eigenvalues, which is equal to determinant A. And product of eigenvalues is lambda 1, lambda 2, lambda 3. Already lambda 1, lambda 2 was given to be 16. So lambda 1, lambda 2, lambda 3 is equal to determinant A value. We have to write it. That is, we have to find out the determinant of a given matrix A. The lambda 1, lambda 2 is 16. That you have to substitute it. And the determinant A, we have to find it. Let's find out the determinant A value now. First, you have to write 6. Okay, 6 into, leaving corresponding rows and columns, remaining numbers you have to write it. Okay, leaving 6 corresponding rows and columns of 6, remaining elements you have to write it. That is, numbers is 3, minus 1, and 3. And next, the formula you have minus. And in the second element in the matrix is that is A12 element is minus 2. So minus 2 into, leave the corresponding rows and columns. That you have to write the determinant, and the elements are the determinant is, leaving corresponding rows and columns, remaining elements you have to write it, minus 2 and then minus 1, 2 and 3. Write it here, minus 2, minus 1, 2 and 3. Plus, in the formula you have plus, the number you have is 2. The last, that is A13 element is 2. 2 into, leaving the remaining corresponding rows and columns, the remaining elements you have to write it. -2, 3, 2 and -1. Now as usual you have to cross multiply it. 6 into 3 into 3 is 9 minus -1 -1. Okay, that is equal to +1. So the formula you have minus is there. So 3 into 3 is 9 minus 1 you have to write it. Okay, so always you start with 3 into 3 multiplication. Plus minus minus it becomes plus 2 into -2 into 3 is 6. 6 minus of -1. Okay, then minus of +2. Sorry, -2 into 3 is 6. 6 minus of -2 which is +2. Plus 2 into -1 minus 2 is 2, minus 2 into 3 is 6. 2 minus 6 you have to write it. So 6 into 8, 9 minus 1 is 8, plus 2 into -6 plus 2 is 4, minus 4 plus 2 into 2 minus 6 is -4. Okay, so or you have 8 into 6 into 8 you have to write it. Which is equal to 6 into 8 is 48 plus 2 into -4 is -8. So -8 minus 4 into 2 is 8. -8 minus 8 is -16. So 48 minus 16 it becomes 32. And already we have lambda1, lambda2 value is equal to 16. Substitute it here. 16 lambda3 is equal to 32. The 16 is taken to the denominator of the right hand side. So you have lambda3 is equal to 32 by 16 which is equal to 2. The third eigenvalue of the given matrix A is 2. Okay, this is the way you have to find out the eigenvalues and the 2 marks question. So using the properties. The fourth problem is 2 of the eigenvalues of A are 2 and 8 is given. We have to find out the third eigenvalue. Here 2 of the eigenvalues are given, which is lambda1 is 8 and lambda1 is 2 and lambda2 is equal to 8. The previous problem product of eigenvalues is given. Here 2 of eigenvalues are given. Okay. We have to find out the third eigenvalue. We take that lambda1 to be 2 and the lambda2 to be 8. So lambda1, lambda2 be the 3 eigenvalues of A, we write it. And here 2 values are given. So which property is suitable for this? Sum of the eigenvalues is equal to trace A. So using that we take it lambda1 value and lambda2. Lambda1 is equal to and lambda2 is equal to 8 is substituted in the property and we can get the answer. We will do it now. Lambda1 plus lambda2 plus lambda3 is equal to the sum of the main diagonal elements 6 plus 3 plus 3. So 6 plus 3 plus 3 is 12. Okay. So lambda1 plus lambda2 plus lambda3 is equal to 12. Given lambda1 is 2 and lambda2 is equal to 8. Substituting these values in lambda1 and lambda2 in the place of lambda1 lambda2, we have 2 plus 8 plus lambda3 is equal to 12, or you have 2 plus 8 is 10. 12 is 10 is taken to other side. So lambda3 is equal to 2, which is the third eigenvalue of the given matrix. Okay, now we will pass on to the next problem. If the system of equations x plus 2y plus z is equal to 0 and 5x plus y plus z is equal to 0 and x plus 5y plus lambda z is equal to 0 has a non-trivial solution, we have to find out the value of that lambda. Okay, using the condition non-trivial solution, we have to find out the value of lambda now. Well, we will find out the solution. The given system of equations has a non-trivial solution. This is the hint given in our problem. So this will helpful to get the value of lambda. That is, whenever the system of equations has non-trivial solution, the condition is determinant A is equal to 0. So we have to find out the determinant A of the matrix, but A is the coefficient of a system. Okay. We have to write the coefficient of x, y, z in the first equation, 1, 2 and 1. In second equation, the coefficient of x, y, z is 5, 1, 1. Write in the second row. And next one is 1, 5 lambda, that is written in the third row, 1, 5 lambda. For this matrix, we have to find out the determinant A and use the condition. We get the answer for lambda. So determinant A is equal to, as usual, find out the determinant 1 into, leave the corresponding rows and columns of this 1. Remaining number is 1, 1, 5 lambda. Write it here, 1, 1, 5 lambda. Minus, formula you have minus, and the number given as 2. Okay, so minus 2 into, leave the corresponding rows and columns of 2. Remaining number, our remaining element we have is 5, 1, 1 and lambda. Write that numbers here, 5, 1, 1 and lambda. Plus 1 into, that one you have to reform the formula, you have plus and 1 is there. So plus 1 into the determinant. Leave the corresponding rows and columns of that 1. And remaining numbers you have to write it 5, 1, 1 and 5. Write it here, 5, 1, 1 and 5, which is equal to, you have to expand this, 1 into, always start here, lambda minus 5. Okay, lambda minus 1 into 5 is 5, minus 2 into 5 lambda, 5 into lambda is 5 lambda minus 1. Okay, 5 lambda minus 1 plus 1 into 5 into 5 is 25 minus 1 into 1 is 1. Now you have to simplify this. 1 is taken inside. So lambda, 1 into lambda is lambda, minus 1 into 5 is 5. Then minus 2 is taken inside. Minus 2 into 5 lambda is minus 10 lambda. Okay, so minus 10 lambda. Minus 2 into minus 1 you have is plus 1. Okay, sorry, plus 2 you have. Plus 25 minus 1 is 24. Okay, sorry, plus 2 you have. Write it, 2 is multiplied with minus 1. So you have plus 2. That is the determinant A. 9 lambda, 10 lambda minus 10 lambda, you have minus 9 lambda. Because largest sign is 10, having minus 10 lambda. So you have minus 9 lambda minus 5 plus 24 plus 2 is 26. Okay, that is the value of the determinant. Minus 9 lambda minus 5 plus 26 is equal to determinant A. Determinant A is 0. Use that condition. Minus 9 lambda plus 21. 26 minus 5 you have plus 21. Or you have to take that plus 21 to other side. So minus 9 lambda is equal to minus 21. Okay, minus 9 lambda is equal to minus 21. You have to take that plus 21 to other side. Now, minus get cancelled. Okay. So, after getting minus get cancelled, remaining term is 9 lambda is equal to 21. Or 9 is taken to other side. Lambda is equal to 21 divided by 9. Here we have 3 times 9 is 3. 3 times 3 is 3. Sorry, 3 times 3 is 9. And 7 times 3 is 21. So, the value of lambda is equal to 7 by 3. Which is the required answer for this problem. Now, the next problem is, if 2 and 3 are eigenvalues of a given matrix A, 3, 10, 5, minus 2, 3, minus 4, 3, 5, 7, find the eigenvalues of A inverse and A cube. We have to find it out. We will see the solution. Let lambda 1, lambda 2, lambda 3 be the 3 eigenvalues of a given matrix A. Okay. And here 2 of the eigenvalues are given. Therefore, we use the property sum of the eigenvalues is equal to trace A. Using that, this will helpful for us to find out. So, trace A is equal to the diagonal elements 3 minus 3, 7. You have to add it. So, 3 minus 3 plus 7, which is 3 get cancelled, remaining is 7. So lambda 1 plus lambda 2, lambda 3 is equal to 7, but lambda 1 is equal to given as 2 and lambda 2 is equal to 3. So substitute those values in that. So 2 plus 3 plus lambda 3 is equal to 7. Or otherwise, 2 plus 3 is 5, and take that to other side, it becomes lambda 3 is equal to 2. 7 minus 5 is equal to 2. So that is the value of lambda 3. Okay, that is third eigenvalue. But we have to find out eigenvalue of A inverse and A cube. Okay, so eigenvalue of A is already 2 eigenvalues are given for A, 2, 3, and we just now find out the eigenvalue, third eigenvalue is 2. Using this eigenvalues, we have to find out the eigenvalues of A inverse and A cube. Okay, so using that, we are using the property of eigenvalues and eigenvectors, we can easily find out eigenvalue of A inverse and A cube for a given matrix A. Okay, so eigenvalue of A inverse is 2 inverse, 2 inverse, 3 inverse, which is equal to inverse can be written as 1 by 2, 1 by 2 and 1 by 3. Okay, next eigenvalue of A cube is equal to 2 cube, 2 cube and 3 cube. Okay, that is whenever you have to find a cube value, then you have to find out the other value. So which is equal to 8, 27. That's it for this video. If you have any doubts, please provide in the comment section. Thanks for watching and thanks for your time. We will see in the next video.